This is a set of data which I've artificially generated that represents blood pressure of people in a population. It has an average value of 120, which I can show by putting on a drop line, chart add element, x-axis reference line, and I make this a thick black line. So we have a thick black line representing the average value. Where do we cut this graph to find unusual values? Is it here, or here, or here? Quite pragmatically, we choose a value that cuts off 95% of the values in the body of the distribution, and we say that if a value is in the tails of the distribution, then it may be unusual. So where do we put this cut-off value? Well, quite pragmatically, we choose a value that cuts off 95% in the body of the distribution and 5% in the tails as our starting point. So how do we arrive at this value of 95% in the body of the distribution? Well, there are two ways of doing it, and it depends upon, do we want the extreme values in just one tail of the distribution? So for example, I'm showing blood pressure here, and if we give somebody a drug to reduce blood pressure, then we'd only expect values on the low side of the distribution. If you get values on the high side of the distribution, then we're not concerned about them. So we would cut off 5% in the one tail on the low hand side and 95% above that. If a particular value that we get is in the one tail of the distribution below a certain point, then we say it is statistically significantly different. If the value is in the body of the distribution, then we say that it could have occurred by chance. So I'm going to do that now. I'm going to move this red line here to actually set a cutoff point. Where we set cutoff points is based on the properties of the normal distribution. For a normally distributed set of data, we know that 1.65 standard deviations will cut off 5% in one tail and 95% in the body of the distribution. And what I've done here is I've moved the line so that it is 1.65 standard deviations away from the mean value. The standard deviation on this histogram is 10 millimeters of mercury. 1.65 times 10 is 16.5. So 16.5 lower than 120 gives us a value of 103.5. So that's where my cutoff line is. So anything which is below this cutoff line is considered to be statistically significantly different from the average value of 120. We could do something very similar for a two-tailed test. For a two-tailed test, we want 95% of in the body of the distribution. So for example, if you didn't know whether the drug was going to increase blood pressure or reduce blood pressure, then we're interested in, if it's in the body of the distribution, the 95% in the middle, then it's not significantly different. If it's either in the tail of the low tail or in the high tail, then it's significantly different. And those cutoff points are at 1.96 standard deviations away from the mean. So here's the same graph, but with two cutoff points at this time. Set to cut off 95% of the values in the body of the distribution, 2.5% of the values in the low tail, 2.5% of the values in the high tail. Again, if the value that we see is in the tail of the distribution here, or it's in the tail of the distribution on the high side, then we say that the value is statistically significantly different from the average value of 120 for a two-tailed test.